Hi, my name is Vidya Bhalodia and I am talking to you about my final project, a big data case study in healthcare. A little bit of background, HCPCS Medicare code 95920 is also known as intraoperative neuromonitoring. IONM is a procedure which involves using classic neurodiagnostic tests to perform real-time assessment of neurologic status in anesthetized patients. This can be critical for patients who have to undergo procedures that pose high risk to the brain, spinal cord, or nerves. From a healthcare payments perspective, this procedure has been performed by a variety of clinicians, variety of specialists with many different backgrounds, and they also have different billing models. So what we want to do is we want to mine the Medicare provider charges database to get some insight into trends and practices. So our goal, get some insight about our IONM code from the publicly available Medicare provider utilization payment database for 2012. Methods, we're going to use PIG to mine the database and extract results for 4 specific questions of interest. Then we're going to use the D3 library in JavaScript to create visualizations for each of the 4 results generated by PIG. And we'll use those visualizations to help identify any trends or outliers in the data. We're going to do all of this on Cloudera's Quick Start VM. It's easy to use. It has pretty much all of the software that we need. You can download it from the link shown. The data, this is just a displayed data from the cms.gov site. You can see there's a lot of information in there, so hopefully we will find some stories of interest. Why are we using PIG for our analyses? PIG is a high-level scripting language for using Hadoop's MapReduce. Like MapReduce for large datasets, it can easily do parallel processing on a cluster. And it also makes it easier to perform a series of MapReduce steps without having to write intricate Java code. Things that may take hundreds or thousands of lines of Java code can easily be done in many cases with a few lines of PIG. So our first question is, we want to understand the distribution of submitted charges. We are going to create a simple histogram. We're going to read the data into the file using our load. With PIG storage, we're going to filter by our code of interest 95920. We're going to select the variables that we're interested in. We're going to define bins of 50 and round and group each of the submitted charges into the nearest 50 and group by them. Then we'll count the number of elements in each bin, and we will save and output the results. Here's the script to do this, and when we run the script, we eventually get this beautiful output, which shows on the left the payment bin, the charges bin, and the number of physicians who file into those average charges bin. Our second question is very similar to the first. Instead of looking at the charges to Medicare, we're looking at the payments that Medicare makes. We're going to do the exact same thing: read the data, filter it, clean it up, define bins of 50, and round our payments to the nearest 50. Count the number of elements in each payment bin, and save and output the results. Same exact code. As a matter of fact, I answered both questions in the same script. It was just easier to do it that way. And you can see that, again, it's a smaller file, less variability in the results, but you can easily see that the payment bins are on the left, the number of physicians that fall in each payment bin are on the right. Question number 3 is, who are the providers of IONM? What are their specialties, and how many patients are they taking care of? And what we're doing here is we're going to do a very similar strategy. We're going to read the data, filter it, and clean it up. Then we're going to group, instead of grouping by payments or charges, we're going to group by specialty. And instead of counting the number of specialists, we're going to sum the total number of patients that each specialty has taken care of. Then we save and output the results. Here's our script to do it. We run the beautiful little blue arrow, start it, and here is our output in the file manager. You can see on the left is the specialty, on the right is the number of patients that have been taken care of. In this case, actually, and I couldn't show it here, but there's 2 output files were created, both with the data in it. And so before I do any further analysis with this, I have to merge. The last question we have is, what percentage of a provider's payments come from 95920? And the strategy is very simple. We're going to again read the data from the file, clean up our variables. For each provider, for each NPI, we're going to calculate the total payments for all of the codes. And then we're going to compare that to, and we're going to merge with all of the payments for only 95920 for each provider. So we filter the data, we filter the input data, we select 95920, and again we calculate the payments. Then we join the two status sets. So we're joining the total neuromonitoring paid and the total Medicare payments over all services. Calculate the percentage of each provider's payments that come from IO numbers compared to their total. And once we have that value, we're going to define the bins, in each bin in groups of 2, group by them. Oh, before I do that, I'm going to show you the output. So on the left, we have each provider's NPI number and the percentage of their money that comes from the IONM code. Then we're going to define the bins. Each bin is going to be 2%. Group, count the number of elements in each bin, create a standard histogram, save and output the results. Here's the script to do it. And here is our output. On the left is the fraction of payments that come from 95920, and on the right is the number of patients or number of physicians who have that many payments. Now we've extracted and analyzed data for all 4 of our questions. Now we want to visualize our result. We're going to use D3 for that. For what is D3? From the website, it tells you that D3 is a JavaScript library for manipulating documents based on data. D3 helps you to bring data to life using HTML, SVG, CSS, whatever you want. D3's emphasis on web standards gives you the full capabilities of modern browsers without tying us into any proprietary framework. So we have a lot of freedom and a lot of power at our disposal. How do we install D3? This is the only installation after we downloaded Cloudera's VM. We download the D3 libraries from the link above. We unzip it into the folder where we're creating our web pages. It just makes referencing it in the HTML much easier. Once we've done that, we start a web server. Now, in the virtual machine, Python comes pre-installed. Python has a very simple web server, which is perfect for our purposes. We just navigate to the folder we're working in. We type in this simple line of code, and we can access our web pages with the URL file://yourpath.yourfile.html. So we're good to go? No, we're doing one more thing. In order to use D3 effectively, we need a header row in our output file. Now, unfortunately, Pig does not have the ability to create header rows. And after a lot of frustration, I realized that the easiest way of fixing the problem is to use a Linux command line to insert headers. It was one line, very simple for the files that I had to work with. Now, to visualize, first question, we're creating the histogram, as you recall, of the submitted charges to Medicare. We're going to read in the data, and here, Pig does not include values that have 0 counts. So we need to fill those so that we have a continuous histogram and where there's gaps where there's 0 values. So what we do is we loop through and we match what our count is to what's in the Pig file. And once we do that, we can configure our display space. We're going to, the size of our display, the x-axis, the y-axis, scaling factors. Then we create the histogram as a group of rectangles all next to each other. We add some text for the x and y axes and scaling for the x and y axes as well. Here's the code for it. And you can see, here's the output. So you can see that there's the vast majority of IONM charges range between about $100 and $1,000. However, and this is where filling in those gaps allows us to see where the gaps are without messing with our scaling. However, there's a small group of providers whose average charges are $1,800 to $2,000, and it would be interesting to understand what about those providers is unique, that their charges are, 2 to 3 times higher than the other providers. Now the next question is a very similar one. Instead of looking at the histogram of charges, we're looking at the histogram of payments. We're using the exact same strategy of reading in data, filling in the missing values, configuring the display space, creating the histogram and the axes. And there's our JavaScript. And it's very similar to our previous code. And one of the things that I did in this case, and I'll go back to it, is before I rescale the axes, you can see it's a very, very broad. There's only 3 bins in it, and it's not a very attractive histogram. You can't, visually it's very hard to decipher one big bar. However, what I did, and you can see it here, is I looped through and I created extra dummy values, extra dummy columns with value 0. And the reason I did that is I wanted to show that not only are the average Medicare payments peak, but they are much, much lower in value compared to the distribution of Medicare charges that the providers submit. So that's an interesting take-home point. There's a large discrepancy between what the providers charge and what Medicare pays them, but Medicare is also very consistent in what it pays. So now we're going to look at our third question, which is looking at the specialties that provide IONM services and how many patients each specialty takes care of. And we're doing a very similar thing. We're going to read in our data. We're going to also, as we're reading in our data, we're going to define the labels that are going to display when we move the mouse over the image. So we're setting up a pie chart that when we move our mouse over a wedge, the specialty and the number of patients will be displayed on the web page. So the code for that is pretty basic. Again, we set up and display our pie chart, and we display the dynamic information when we mouse over each particular wedge. Here's the JavaScript code. Here's the pie chart, and you can see from the screenshot that I'd moused over neurology, and on the bottom of the screen you can see that it says neurology and 43,000 and change patients. For the final question, it's the same basic thing that we did for questions 1 and 2. We're going to read in the data, fill in the missing values, configure our display case, create and display the histogram and axes. And what we see is this is our JavaScript code. When we run it, we get a histogram similar to what we had previously, where we can look at the percentage of reimbursements that come from HCPCS code 95920. And what we find is that for the most part, most physicians or most providers who provide IONM services, most of their reimbursement comes from other sources. Very few providers have half or more of their reimbursements come from this one particular code. For most of them, it's less than 30% of their total reimbursement. However, there is a small group of providers right here where all of their reimbursements come from this particular code. And that's a little bit interesting. It may be an error, it might be a typo in the data, it might be the way that Medicare processes the data before releasing it, that providers typically cannot bill for this code by itself. They typically have to bill it for other codes. So that's something that if we had access to more detailed data, we would look into. So in conclusion, using PIG to process the data and visualizing the data in D3 were a pretty good combination. We saw some trends in the data. We identified some outliers that might be useful if we were in a real healthcare environment in optimizing our reimbursements. The only fundamental complication I ran into was that D3 needed a header row to work effectively, and PIG can't produce one, but I was also able to find an easy workaround. So it was an interesting, educational, and beneficial challenge. Thank you. Have a good summer.